right? So we'll take one by one. So how the splitting happens, students? We'll just take a look at what are the complex ion and the counter ion present in this complex ion and the counter ion in this complex ion and a counter ion, right? So this one, for example, see, for Cu ammonia 4 times 2 plus SO4 minus 2. It should be 2 plus because that is the reason we have used SO4 minus 2. Otherwise we would have used something else, right? Negative charge, 2 negative charge it is having. That means the complex ion should be having a positive charge. So the complex ion is Cu ammonia 4 times 2 plus. This is the complex ion, and the counter ion here is SO4 2 minus. Very clear? SO4 2 minus. Clear? Same is the case. For example, this is CO ammonia 6 times. This has to be 3 plus, student, because there are 3 Cl minus ions are there. So the number of the charge which is carried by the complex ion, same, the ion, the same charge will be countered by the counter ion. So that is why we call it as a counter ion. Counter ion will be countering the positive charge or the negative charge developed by the complex ion, so that the entire system becomes neutral, right? So in the solid state it will be existing like this. That is, when you put it in solution, we'll be having the splitting. That we will go through again afterwards. So let us just take a look at the complex ion which is present. CO ammonia 6 times. This has to be 3 plus, students, and there are 3 Cl minus ions are there as a counter ion. Clear, right? So as far as this is considered, how many Cl minus ions are there? 2 Cl minus ions. That means the charge on the complex ion should be plus 2. That is CO water 6 times 2 plus is the complex ion, and the 2 Cl minus ions are present as a counter ion. Very clear? As far as this is considered, this is a positive charged counter ion is there. That means 4 positive charged counter ions are there, right? 4 positively charged counter ions are there. That means the charge on the complex is minus 4, right? This is a plus 4. So the complex ion here is FeCN 6 times 4 minus, and we have 4K plus ion as a counter ion. 4K plus ion as a counter ion. Here it is a neutral complex, students. That is, only we have a complex ion NiCO 4 times. Charge on the complex is 0, so you don't need any counter ion for this. Very clear? You don't need any counter ion for this. So if you look at this, students, we have come to know that there are 3 kinds of complex ions may be possible. In a way, we can say there are 3 types of coordination compounds or coordination complex. I will repeat again. If you see the complex ion is the one which decides the property of the coordination complex. So coordination complex, the main aspect is this. Counter ion is just to counter the positive or the negative charge developed by the complex ion. Very clear? So I'll just repeat, students. So if you look at the complex ion, we came to know that there are 3 types of the complex ion can be having. That is, you can have a positively charged complex ion, you can have a negatively charged complex ion, or you can have even the neutral complex ion, or in other words, neutral complex, or in other words, coordination compounds can be coordination complexes can be subdivided into 3 classes. One is, I can say, cationic complexes. One another is anionic complexes, and one more thing is neutral complex. If at all they ask you which of the following is an example for a neutral complex, which of the following is an example for cationic or anionic complex, you need to look at the complex ion. If it carries a positive charge, then it is a cationic complex. If it carries a negative charge, then it is an anionic complex. If it doesn't carry any charge, then it is a neutral complex. Then it is a neutral complex. Make it clear. So these three are cationic complexes, and this is an anionic complex, and this is a neutral complex. Very clear. So this is a basic aspect. So these kinds of question could be raised in a level 1 question it is, which could be raised in the competitive examination. Just keep it in mind. So now let us take a look at students. So let us try to emphasize on the throw light on the complex ion, because that is the one which decides the property of the coordination complex, right? So we'll take a look at the complex ion in specific. Okay, so complex ion will take a look at. I'll just rub this portion. Complex ion of this, the copper complex, cobalt complex, iron complex, and nickel complex. We'll just take a look at the complex ion or complex as such, right? See, in the complex ion, students, see, there are two parts again in the complex ion. Any complex ion for that matter, or the coordination complex for that matter, again there are two parts are there. Again there are two parts are there. One is there is a central metal ion. Central metal ion will be having. Second thing we will be having is ligand. We'll be having ligand. Alright. So I'll just take a look. We'll just take a look at the ligand. So we have a central metal ion. Generally the central metal ion will be transition metal ion. Mostly we'll be using transition metal ions in the coordination complex. Transition metal ion. Whereas the ligand is basically one which has a lone pair of electron, or one which is a Lewis base, or I can say it is a Lewis base. Ligand is a Lewis base. What it means to say that, students, what happens is in all the complex ion for that matter, any complex ion for that matter, what happens is you have a central metal ion M, ligand will donate a lone pair of electron to the central metal ion, or in other words, ligand acts like a Lewis base, that is, it gives a pair of electron. Metal acts as a Lewis acid. Metal acts like a Lewis acid. Very clear. So ligand will pass a lone pair of electron to the central metal ion, or in other words, the coordination bond will be established between the ligand and the metal ion, that is a coordination bond in which the lone pair of electron being given to the metal will be established. So hence we will be having a coordination bond like this. So what kind of the bond is present between the central metal ion and the ligand in the complex ion or the coordination complexes? It is the coordination bond, only the coordination bond. A ligand, or we can say that, student, ligand, what is a ligand? Ligand is the one which donates the lone pair of electron to the central metal ion and establishes a coordination bond. Establishes a coordination bond between a ligand and the metal. That is why we call it as a coordination complex, because the only one kind of the bond, mainly, in the coordination complex, the one kind of the bond we'll be having is coordination bond. We have a back bonding also, it's very rare in the carbonyl complexes and all that we will go through. So the main bond which is present is, which made us to say it is a coordination compound, is the coordination bond between the ligand and the metal. So ligand donates a lone pair of electron to the central metal ion. So let us take a look at the ligands, students, in detail. In detail we'll take a look at the ligands before slipping on to the other aspects of the coordination compounds. We'll just take a look at the ligands. So as I already said, ligand is the one. So before that, we'll just take a look, student, here. This is the metal ion, ammonia is the ligand. How many ligands are there? 4 ligands are there. This is metal ion present here is cobalt, and the ligand present here is ammonia. Cobalt is the metal ion again, and the ligand present is water. Here the cyanide ion is the ligand, and here the carbonyl is the ligand present. As far as the ligand is considered, students, that is, the primary requirement is it should be able to have able to give lone pair of electron to the central metal ion. It can give one lone pair of electron, or it can give one lone pair of electron, or it can establish one coordination bond. One coordination bond. That means it has to have one, it will be having one lone pair, it will be giving to the central metal ion, or it can establish one coordination bond with the central metal ion.